Let's look at the second example of the Bernoulli equation. This is a more or less a straightforward example, but it's good to just warm up and understand how things or how the velocity between 2 points or the pressure between 2 points can be calculated. Again, we have the flow running through like a pipe, expanding pipe. So this is an expanding pipe here in this case. Is inclined upwards. Okay, the pipe is inclined upwards. You can see here. So between 0.1 and 0.2, the difference is like 0.3 meters. So we know the difference, only we need that parameter. We don't need to have the elevation from any like the point. As long as you can see the relative like the difference is fine. Velocity 1 and velocity 2 has been calculated. Velocity 1 is at 3.1 meters per second, and velocity 2 is like 1.7 meters per second. And the pressure at point 1, atmospheric pressure, not atmospheric, sorry, the relative pressure is given to us like 0.3 1,000 newtons per square meter. So the question is that to calculate the pressure at point 2. So, and the assumption is that we don't have any energy loss. So without any energy loss, you can write the Bernoulli equation. If you have energy loss, the energy on the left-hand side is equal to the energy on the right-hand side plus any total types of the energy loss that we will discuss it in chapter 6. So we have like this equation. The only thing that you need to do is to just substitute the figure that we have. Z1 and Z2 is given to us. We don't need to just have the value. As long as we have like a differences, it's absolutely fine. Or you can just draw the line through the point 1. So obviously Z1 is 0 and Z2 is equal to the difference is like a 0.3. And V1 and V2 is given to us. P1 is given, P1 over rho G is given to us. The only thing that you need to do is to just substitute the value and calculate the P2. We're just going to put everything here. So you can see Z1 is 0, Z2 is like 0.3 meters, and V1 is like a 3.1 on the left-hand side. You can see here squared over 2G is like a 2.9.81, or you can just sometimes just use this term 19.62 plus P1. P1 pressure at this point is given 9.3 thousandths divided by 1,000 like the rho of the water and times 9.81 for G. Okay, so this is equal to 0.3 is like the relative, not relative, like the elevation head for 0.2, plus P2 over rho G, and plus the velocity 0.2. So P2 is like the unknown variable. So the V2 is like the given to us 1.7 squared over 19.62. So if you rearrange or simplify all of this kind of like a fraction, we're just going to have this line. And if you rearrange the formula, P2 over rho G is equal to 0.991 meters of water. And if you are told to calculate the pressure in newtons per square meter, you need to just carry on and to rearrange this one and calculate P2 exactly. P2 is equal to 0.91 times thousands of like water of the water here. I'm just going to calculate this one here. And times 9.81 is the gravity acceleration. So the result is 9.72 thousand newtons per square meter. So this is example 2 of the energy or Bernoulli equation.